So today what we're going to do is we're going to continue looking at ways we can measure and think about statistical data. And today we're going to be talking about what are called measures of spread. And you've heard the word spread before. If things are spread out, that's just how they're distributed along. So if we spread out all your books across the floor and then measured them, right, we would know how long a line they would make, for example. So we're going to be looking at how spread translates to our data. Okay? And we're going to look at a couple of different measures of spread. The most important one is something called the range. And then we're going to build on that later as we go. So today we're going to do something quite simple, talk about range. So let's go to our book. All right. So last time we were here, we looked at measures of center. We wanted to see what was happening in the middle of the data. And to do that, we used mean, median, and mode. Right? So you had some exercises where you were looking at mean, median, and mode. Well, today what we're going to do is we're going to look at one of the measures of spread, and that measure is something called the range. And the range is easy to find, and I'm also going to talk to you about something else. When you're talking about range, you're simply going to take the maximum value. What does maximum mean? The biggest value. Good. And subtract the minimum value from it. And what's the minimum value mean? The smallest one. Yeah, the lowest number. Okay? So you're just going to take the maximum minus the minimum. Because what we're talking about here is change. How much change is there from one end of the data to the other? And anytime you're measuring change, you're always going to take the end minus the beginning. And so always keep that in mind. When measuring change later, you're going to see it's always the end minus the beginning. So we're going to look at a few calculations using range. Very easy, right? And you don't even have to subtract because you've got your calculator with you. So let's just look at some of these problems. So here in the example, 17 students were asked how many days they stayed home sick from school so far this year, and they gave you the results. Find the range of this data set. Well, if you're working with any data set, it pays to be organized. And about organized with numbers, what does that mean? Put them in numerical order, you betcha. So, because if we don't have to do it for mean, we don't have to do it for mode, although it makes the mode a lot easier to find. But we always have to do it for what? Median, right? And it certainly makes your life easier to do it for range. Now, I could just search through here and see that 1 is the smallest number. That 1 is the smallest number and that 9 is the biggest number. So you don't technically have to, but it's always a good idea if you have a small amount of numbers. Now, if I had 50 numbers, I don't want to have to put them all in order, right? But if you have a small group of data like this, then you can. So the largest number in this case is 9. The smallest number in this case is 1, which gives us a range of 8. And do not ever forget, you must have units. If you just say 8, then I'm going to count it wrong. If you don't show me 9 minus 1, in other words, I need to see the working, then I'm going to count it wrong, right? Because this is a math class. It's all about demonstrating that you can manipulate the numbers, right? So you need to write them down. Okay? Really, really, really hard work today, yeah? Okay, so let's go to the exercises, and we'll just do a couple of these together. So look at 1, I don't know, let's just do 1D. I'm feeling D today. Here we go. So, what I want you to do is find the range. Go. Sometimes you're going to be given the data in another way. So here we have some where we're giving them as graphs. So we need to, and a stem and leaf plot. So we need to be able to find our range there. Let's look at the stem and leaf plot because it's a very good one to use because it's very easy in a stem and leaf plot to find the maximum and minimum. Why is it so easy in a stem and leaf plot? Yeah, the stems and the leaves, so it's already organized with the numbers in order always. The first one is always the smallest one, and the last leaf of the bottom stem is always the biggest one, right? As long as they're in order, which they must be, otherwise it's not a proper stem and leaf plot. Look at your numbers. Shh. Look at your let me finish my question before you answer your question. You can raise your hand, please. Okay? All right. Now, as long as they're in order. If it's not in order, then your stem and leaf plot's not finished, though, is it? Okay? Yes?
How do you know if it's units if you saw the graph?
They'll tell you units, but there aren't. Do you have any here? No? But like you could be, like if you have this graph, it could say the number of days or something.
Okay.
But they'd have to give you a title. Okay? Yes?
What's the stem and leaf?
Not going there yet. Hold on. All right.
It's a plot. We did it.
Guys, it is so with a stem and leaf plot, the very first value, the first stem and the first leaf is always the smallest digit. The last stem and the last leaf is always the biggest digit. And we have our scale there so that these are the tens and these are the ones. So somebody tell me then, please just sing it out, everybody working together. What is the largest number in this particular?
58.
58. Minus, what is the smallest? Shh, guys. And then I simply need to subtract those two, which gives me a range of what?
I don't know.
Okay.
It does.
Right.
5.
Okay, so variation is simply another way of talking about the range, how much things vary. Okay, so we're going to go to our snowflake and we're going to do some work on these, just practicing.